Hi guys, myself Vijetha Vardhan, and in this video lecture session I am going to show you a solution on projection of plane surfaces. And an example problem is like this. A circular lamina of 50 mm diameter rests on VP such that one of its diameter is inclined at 30 degree to VP and 45 degree to HP. Draw its top and front view in this position. According to the given condition, a 50 mm circle having a diameter is supposed to be on VP. So for which one has to go for circle by center point command, and line thickness is 0.5 millimeter and set the diameter as 50 or radius as 25. Place it in the VP. Now circle doesn't have a corners, for which one has to create it by using a line command. Just draw one of the radius, and once the radius has been completed, and then select that radius line using circular pattern. The total angle of the circle is 360 and it is supposed to be divided by 8 equal parts, and fix the center points. Click on the finish. Now one can see that the circle is divided into 8 equal parts. Then to draw the top view using the projectors, using the line command with respect to 0.13 mm as a thickness, and start drawing the projectors from each and every end points of a lines what we have created now, which is divided into 8 equal parts. And after this, using a line command with a thickness of 0.5 millimeter, join the top view as a split line so that we can make use of these split lines in the next stages to draw the front views and the top views in the second stage. Now name the corner as A dash, and this corner as B dash, and this corner as C dash, this corner as D dash, this corner as D dash, this corner as F dash, this corner as F dash, and this is supposed to be E dash, so we'll mark it as E dash, and then this is going to be G dash, and this is going to be H dash. Accordingly, in the top view, this will be named as A, and B as well as H, and then C as well as G, and then we have D as well as F, and finally we have the corner E. Once this is finished, the lamina is inclined at 30 degree to VP. Now 30 degree to VP, so one has to select the top view, go to a move command, move in such a way that with respect to the corner A, it should be repositioned on the XY line, and go to a rotate command and make sure that A is on the XY line and E is moving away from the XY line at an angle of 30 degree with VP. Now 30 degree with VP is being selected. Then make use of a line command with a thickness of 0.13. Draw the projectors of each and every corners so that we can draw the front view. Now for which, now the endpoint symbol is going to be taken as a reference. One can able to easily draw the projectors. Now the angle of this line is supposed to be 90 degree, so we'll lock it as 90 degree. Now one can see that the point is shifted, so we will redraw that line. That is, B and H is going to be a proper vertical line, and CG is going to be a proper vertical line, and then we will get the point of G. Then make use of the angle between command, show that the angle between these two lines is supposed to be 30 degree. Then make use of a text command, name the respective corner. This will be named as A dash, this will be named as B dash, and this will be named as D dash, and E dash, F dash, G dash, and finally this is going to be the H dash. Now we didn't get the C dash properly, so we'll recreate that C dash point using the text command. Then make use of ellipse by center point with a thickness of 0.5 millimeter. The intersection of these two diameters are the center point. First select the E dash as a reference, and then the tangential point of C dash as a reference. Now you can see we have got the required front view as a ellipse, and afterwards the diameter is inclined at 45 degree to HP. Now AE is inclined at 30 degree. Now AE is again inclined at 45 degree. So for which one has to draw the 45 degree line like this. Now one will draw the 45-degree line. One will draw the 45-degree line like this. Then make use of angle between command. Show that the angle between these two lines is supposed to be 45 degree. And afterwards, measure the diameters. That is, A dash to E dash is measuring as 50 millimeter, whereas A dash to E dash here it is reducing to 43.3 millimeter. So for which one has to construct an apparent angle. Now to construct an apparent angle, we know that, so let us select this as A dash and this as E dash. Then make use of a point command with respect to 2 mm as a thickness. We'll take this position as the start point. Now this point will be taken as E dash. Then from E dash, using a arc by center point and radius as 0.13 mm thin, and the point what we have created, that has to be centered, and the first radius is supposed to be a 50 millimeter. One has to draw an arc here. Now after drawing an arc, one has to draw a locus. The arc is supposed to be constructed on the other side. So we'll construct the arc on the other side. Once again we'll repeat it. So the radius is supposed to be 50. The arc is supposed to be drawn on this side, and using a line command, draw the locus. And after drawing a locus, again go to arc by center point. Whatever the point we have created is supposed to be taken as reference, and the radius is supposed to be 43.3 millimeter, and draw one more arc with respect to the locus line. And then make use of a line command with respect to thickness of 0.13. Join this line. This is called as apparent length, and using an angle between command, show that the apparent angle is 55 degree. Then select the front view and move this front view with respect to the corner A and E properly on the respective points. Now using the move command, I will position that E is over E here. Then using the rotate command, I will rotate that corner E dash with respect to A dash like this. Now one can see that we don't have selected the projectors, so we'll repeat the step. We'll select the front view, then select any 3 projectors like this, and then go to a move command, then go with E dash, and we know that this is point E dash, and then go to a rotate command. Rotate in such a way that E dash is supposed to be here and A dash is going to be shifted on the beta endpoint line. Now one can see that we have drawn the required projectors. Then make use of a line command with respect to 0.13 as a thickness. Start drawing the projectors from the right extreme corners. So let us start with C. So C is going to be projected to C to C. Now along with C we have G also. So we'll get the position of G. So G is going to be the shear point like this. And then we have D dash. So D dash is going to be at this location. So along with D we have F also. So we'll project the F also on the same line. Then we have E. E is going to be projected here. So E is going to be connected to E. Then BHA is remaining. So B is going to be the intersection point and B is at this location. Now we have to select B to be properly, but one can see that this is not 90 degree. So log the angle as 90 degree, and then the remaining point is H dash. So connect H dash on this line, and A is on the XY line. So project A on the XY line. Again log the angle as 90 degree and click on the XY line. Then whatever the extension lines we have drawn for the projectors can be deleted. Then make use of a text command, name the respective corners as A, and this as B, and this as C, this as D, and this as E, this as F, and this as G, and this as H. Then make use of curve command with respect to 0.5 mm as a thickness. Connect A to B, B to C, and then again C to D, D to E, and again E to F and F to G, and then again, we'll repeat it, E to F sorry, E to F, F to G, G to H, and H to E. Now one can see that the projection has been completed in all aspects. Now the problem is finished, and if you have any sort of doubts, you can feel free to contact me. And please do subscribe to my YouTube channel, and also do share this video to all your first year engineering students. And once again, thanks for watching my video.